Hi everyone, this video is going to cover the first half of the section of, it's actually a combination of two sections, section 8.5 and 8.6. I'm going to teach them together in two different parts. So the first thing that we need to get down is a bit of terminology. Okay, I've got triangle ABC here. Okay, across from vertex capital letter C, I'm going to have a lowercase c. Across from vertex A, I'll have lowercase a for side A, and across from vertex B, I'll have a lowercase b for side B. Let's look at angle B. I'll highlight it in blue. And from the perspective of angle B, we would say that the leg of the right triangle opposite angle B is side B. The leg adjacent or next to, vertex or angle B is side A. Now, why A and not C? Well, I said leg. C is the hypotenuse. So we will not call it the leg adjacent. We'll just simply refer to it as the hypotenuse. Okay. Let's highlight angle A in green. And then from angle A, things look a little different. Now, the hypotenuse doesn't change. Hypotenuse is always C. But opposite angle A is side A. And then the leg adjacent to A, adjacent next to, is actually B. And you can see that these two have opposite answers. It depends on your perspective. Why do I bring this up? Well, I've been hinting for a while that you guys are going to learn about these functions called the sine, the cosine, and the tangent. What these functions are ratios of sides of right triangles. The sine is the opposite side over the hypotenuse. A ratio of two sides of a triangle, the opposite side of the triangle over the hypotenuse. The cosine is the adjacent leg over the hypotenuse. ADJ for adjacent. The tangent is the opposite side over the adjacent side. Okay, so specifically for angle A, opposite angle A would be side A, and of course the hypotenuse is C. In the diagram above, adjacent to side A, to angle A is side B, and then the hypotenuse is C. And then opposite, we've already covered, is side A. Adjacent is side B. Okay. But things look different. Okay, again, we're going to change our perspective. Now we're using side B, so I'll highlight those in the same color that we were using before, okay, for angle B. Let's see. Sine B, that's opposite over hypotenuse. That would be side B over C, the hypotenuse. The cosine of angle B, that would be adjacent over hypotenuse. Okay. Well, adjacent to B is, angle B is side A. And then the tangent is the opposite over the adjacent side. So the tangent of angle B is B over A. You can see the difference between the two. The top four all have hypotenuse values of C, but the A's and B's change depending on which angle you're using. And then you can see for the tangent of A versus the tangent of B, they're reciprocals. Okay. What about angle C? How come we haven't taken the sine or cosine? Well, we don't define those values for angle C for the 90-degree angle. Okay, we're going to be using the acute angles in a right triangle when we're using sine, cosine, and tangent. How are you going to remember all of this? Okay, well, there's a mnemonic. It's kind of silly. This is pretty much how everybody remembers this. And it's this acronym, really, called SOHCAHTOA. SOHCAHTOA. What does that stand for? Well, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. SOHCAHTOA. Okay, so you should write that down on your test as soon as you get them so that you can remember how all these ratios work. The values of sine, cosine, and tangent depend only on the size of the angle. Okay? By dividing a side by a side, the units of the sides will cancel out, okay? And it becomes simply a ratio that indicates the size of the angle opposite. We can find out the appropriate value of each sine, cosine, and tangent for any given angle by using our calculator. Okay? So, you will need to have your calculators out for this next portion to follow along. Write this. I'm going to do number 1. It says write the sine, cosine, tangent ratio for angles x, y, and z. Okay. All right. So for angle x, okay, here's angle x. I'm sorry, we're not going to do it for z. We're only going to do it for x. I misspoke. Okay. Let's do angle x. Okay. The sine of angle x is equal to the opposite side. Now what's opposite x? 40. The hypotenuse is a little easier to spot. It's across from the 90-degree angle, 41. Cosine. Okay. Reminder, that's adjacent over hypotenuse. The adjacent side to angle x would be 9. The hypotenuse is 41. The tangent of angle x, if you recall, tangent TOA, opposite over adjacent, opposite being 40, adjacent being 9. Now, from y, let's highlight y. The sine of y, that should be opposite over hypotenuse. Opposite side from y is 9. Hypotenuse is 41. The cosine of y is adjacent over hypotenuse. Now, adjacent to y, the leg that it's touching is 40. The hypotenuse is 41. The tangent of y, again, opposite over adjacent. And we already see that the opposite is 9. The adjacent we had already found is 40, so 9/40. Okay. I'll let you try these 2 examples in a few minutes, and then I'll make a video, or probably just load a answer key with the worked out solutions for any problems I don't do in this video. All right, now we need an example where we actually do some solving, okay? And this is where you'll need your calculator, okay? So looking at this number 1, triangle ABC, okay, we have 25, okay, 1 side length, and we have 1 angle length. Okay. We want to find 2 side lengths. Now we can't use Pythagorean. We cannot use Pythagorean because we do not have 2 sides of the right triangle. Okay. What we have is an angle and 1 side. So we are going to use either the sine, the cosine, or the tangent. So let's write SOHCAHTOA at the top of our page. Okay. For 37, from the perspective of angle B, or 37 degrees, we have the adjacent side. Okay, so we want to use a trig function that has a capital A in it. So right now my options are cosine, CAH, and tangent, TOA. Now, I actually need both of those things. Okay, from the perspective of 37, x is the opposite side, and of course y is the hypotenuse. Okay, I need both of those things to get through the problem. So it doesn't really matter which one of these you start with. I'll start with cosine. Cosine of 37 should be the adjacent side, adjacent being 25, over the hypotenuse, which I don't know. Okay. I now have to solve for y. Okay. Now, I have to get y out of this fraction. How do you get y out of this fraction? Well, first off, I'm going to get this cosine a little bit closer to 37 degrees here. I am going to multiply both sides of the equation by y to get it out of the denominator. So it cancels on this side, okay, but on the other side we get y times the cosine of 37 degrees equals 25. Now, of course, to solve for y, we're going to divide by cosine 37 degrees on both sides. So now we have y equals 25 over cosine 37 degrees. Okay. Get your calculator out. Turn it on. I'll clear this menu. Okay, the first thing that we all have to do is we have to hit the mode button. The mode button is up here but next to the second key. Typically, a calculator whose memory has been cleared or is new from the store will be on radian mode, and we don't want that. We want degrees. So cancel out of that, or once you've pressed degree and highlighted it by pressing on enter, you're going to cancel out of that by pressing second, then quit. We want to know what 25 divided by cosine 37 is. Okay. And we see the sine, the cosine, and the tangent buttons right in the middle of your calculator buttons here. Okay, we'll press enter, and how about for now we'll round to the 10th place. Okay, 31.3. Okay, for these you are going to have to round. Many values do not give an integer value for their sine, cosine, and tangent values, so we'll have to do some rounding here. So we're going to get 31.3. Why is 31.3? All right, I'm not done yet. I do need to find, I found the hypotenuse. I do need to find x, which is the opposite side from 37. Okay. So here's what I'm going to do. I need to write a ratio with the opposite side and the adjacent side, O and A. That gives me tangent. So I can write tangent 37 degrees equals opposite, sorry about that, the opposite side is x, the adjacent side is 25. Now this is a little easier. What do I want to do on both sides? I want to multiply by 25. Okay, so I get 25 tangent 37 equals x. Get your calculator out. Okay, and type 25 tangent 37. Press enter, and we get 18.8 if we round to the 10th place. So x equals 18.8. Okay. We'll box that along with y equals 31.3. Check your answer for reasonability. Makes sense to have those two values in a right triangle. Hypotenuse is the longest side. Okay. Now I'll give you guys the chance to try the rest of the problems on this page only. We will save this third page for another class. So right now, just try the number 2 and 3 from the first page and everything on the second page.